So, Здравствуйте. By the way, this is not Russian. My T-shirt says "Видзеркалье реальность," which means reflected reality, which is why it's written backwards, and it's in Ukrainian. You have to look in a mirror to see it the right way around, but even then. So I'm going to talk today about schema.org. I'm Charles. I work at Yandex. How many people have heard of Charles? Don't worry about that. How many people use schema.org today? A couple. How many people have think they have some idea of what it is? And how many people are like, tell me what schema.org is? Okay, so we've got a big mix. And how many people know Yandex? How many people have used Yandex? You've heard of it. So half of you haven't heard of it. In California, Yandex is sort of like some random startup. It's actually $1 billion company in Russia. It's a search engine that does maps and mail and money transfer and music and markets and even things that don't start with M. It's a big company in Russia. It does about 60% of all search in Russia on the web. So it's one of the few markets where Google is not at all dominant. But it's mostly been a Russian company. Enough advertising. What is schema.org? Right, what's the point of schema.org? Schema.org is tagging. Right? It's a way of putting tags in web pages. So, it's not quite like XML. It's, as I put on the title page, it's like metadata, like it's 1999. When search engines started being a big deal in the mid-90s, people were like, we're going to catalog the web. And so we're going to have to put all of this metadata in our pages so that search engines find us. And you may remember, if you're old enough, things like meta keywords and descriptions and stuff, and that was going to go in search engines, and you'd suddenly magically rise to the top, right? And you'd use stuff like Dublin Core. And it was great, except it didn't happen. Search engines didn't use much of the metadata that you put in your pages. Does anyone know why?
Larry Page decided to circumvent the whole thing.
Well, Larry and other search engine people said, we're not going to do that. But there was a very sound reason for it, which is basically metadata, because it's not visible stuff in the page, would just get stuffed with spam terms for climbing up the search engine. So you'd go and look for any kind of information, and there'd be some page that had lots of the right keywords and the right description, and you'd open it up and it'd be yet another porn site. It was basically used for spamming search engines, and that meant we couldn't rely on the results. So search engines stopped doing it. People who collect their own information and manage their own information, they use that stuff. People who do metadata, as my mother says, because that's what she does, library people, they've been using structured data in their content in order to look after it and manage it, but it never worked on the open web, right? It worked in structured search engines in libraries all over the world and inside companies that organize their information. And we've seen a bunch of stuff. I've mentioned some names here. I think I'll just skip them because they'll come up again. So schema.org is metadata for search engines. You put labels in your pages, keywords in your pages, and search engines do actually read it. And why, right? What's the difference between 1999 and now? Y2K went by. A few other things went by. We have a pope from Argentina. We have we have peace in our time. But we, the search engine companies, have massive amounts of anti-spam detection and analysis to block spamming and to block black hat SEO. So we're much more confident now in our ability to look at a page which has keywords all about, whatever it is you were looking for, football stadiums for children or rowing clubs, and discover whether it really is a rowing club or a porn site. So we are able to do much more with the data, to rely on it more, because we can quickly detect when people are telling lies. And Schema.org is an initiative. It came from Google, but it's Yandex, Yahoo, Microsoft, like the Bing team, and Google are the 4 groups that are involved in driving it and making it happen. I'll come back to that at the end of the talk. And yeah, it's keywords, right? It's tagging things. It's not rocket surgery, it's page descriptions. This web page is about a business. Right? We sell wigwams for Goose's Bridals, and we're located on, one suburban street, and our telephone number is something. Or this is a picture, a creative work, and it was created by somebody, and it's published somewhere. Information about a book, information about events. So, if, for example, you ever had a web page for a kind of web conference, you might find that page would say, well, what is this page? It's the page about an event. An event, might have a date like the 12th of July, and a location like PayPal Campus, and a name like Open Web Camp. And you put this data in and you mark it up, right? You put explicit data to say, this is the name, this is the location, this is the type of thing, conference, or a flight, or a language. There's a whole vocabulary which I won't bother showing you. No, I will show you just quickly what you have. This is all of the things in Schema.org. Blah, blah, blah. It's just a giant list of terms and properties. So I'll tell you what I mean. A term is a thing, right? An organization. An organization has properties like its name. It might have a location. It might have 50 locations because it's a multinational company that has offices everywhere, and they sell burgers. The location might be a specific type of location. So you have a location which is a burger restaurant. And there's all these terms in here. You can look at them at your leisure, and I'm going to skip them now. And the basic idea is it's easy. Right? You take some HTML. What I have here is a couple of spans. Catcher in the Rye by J.D. Salinger. And Catcher in the Rye, I've made that a span, and I've used, in this example, Microdata, which is a part of the HTML5 work, to say we have item scope. So we have all of the things I'm talking about in here are of type Schema.org book. We're talking about a book. And it's got a name, and it's got an author, and there's a URL to the wiki page, the Wikipedia page, which doesn't fit on my screen because that's how presentations go. But you can imagine the end of the URL. We started out using Microdata, which is one way of doing markup. You put attributes inside your HTML, so it's not very complicated. You just highlight something and tag it. You say, I'm using Schema.org book. This is the author. This is the thing. RDFA is a different way of doing the same thing. How different? At first glance, trivially different, right? Instead of saying item prop equals schema.org something, we say vocab and type of. You know, instead of saying item type is a name, we say property is a name. You can look at RDFA or Microdata, pick which tool suits you better, and use that. Basically, when you use this markup in your pages, you know, we, the search engines who are indexing it, we go looking for this stuff on purpose. We want it. JSON LD is another way of doing exactly the same thing. The difference is when you have JSON LD, you know, it sits in a script tag on its own. Right? It doesn't appear on the page anywhere. It's invisible. But it's the same, you know, this information and the page before, you know, they say the same things. Right? You have a name and a business with a name and a phone number. So there are a few different ways, a few different formats you can use to put your data into your page. This really depends on your tool chain. How big is the uptake? It's big. In our indexes, and you know, each of those search companies has their own index. No one will tell you how many things are in their index. Google might, because everyone believes they're the biggest. So they might say actually how many things they find. Everyone doesn't want you to know how much bigger or smaller they are. But all of us in our index find about 10% of the content is using schema.org markup. It's only been around for a couple of years, so that's 3 years. So that's a pretty fast uptake. That's a very big distribution of content on the web, partly because a lot of the stuff on the web is old, right? So a lot of stuff that's new and a lot of big services are using this markup to make it possible to find things and to really know what they are. So what does schema.org describe? You know, as well as describes all kinds of things. You know, you can describe a volcano. Turns out you can give you say this page is about a volcano and here is the volcano's fax number and opening hours. It's very useful to know when a volcano's opening hours are. Well, yeah, it turns out that no one's actually, as far as we know, marked up the opening hours of a volcano. You know, medical conditions. Movie rental stores. How many people have been in their life to a movie rental store? This is a kind of local business, right? It's a physical location. You can mark the defense establishment, you know, sort of thing you find all over the web, all over the web. It's like, oh, where's my local defense establishment? I might wander down and pay them a visit. HVAC business. I saw that. I think, what is an HVAC business? So I looked in, you know, the documentation and said, HVAC business and HVAC business. Okay. So, you know, someone told me what that really is. It's heating, ventilation, and air conditioning. Who knew? But there's a lot of detail in there. You know, everything. You can describe all kinds of things. I should have put an asterisk here too, but I didn't. Some of the fundamental ideas behind schema.org were keep it simple. Right? Why do we use this really simple RDF, A, or microdata markup? If it's simple, people get it right. You know, if we make some really complicated, super powerful, super precise ontology describing every single thing, people get it wrong. If we ask webmasters to decide whether they're talking about an event invitation or, you know, a possibility of going to an event or, you know, a notice of an event that you can turn up to, they will randomly choose one of the three, and we will have to handle all three, and that just means you do a whole lot of aliasing and you get no value, right? None of these terms, if the terms aren't different from each other in ways that simple developers understand, and in my case, in Russia, where most developers' level of English is pretty basic, if they don't understand the difference, they're not going to get it right. So it's really important to actually keep it very simple. It's a very flat structure. Everything, to a rough approximation, everything in schema.org, every term, every type, has a name, and its URL is http schema.org/whatever. That's it. There's no complicated nesting paths and substructure in the way things are named. There are locations, and then there are subtypes of location. So you can have a location, this is a location, or you can have, this location is a movie rental store, which is a type of location. It's also a type of business. And there are very basic data types. You have text, you have URLs, dates, times, and you can have float or integer numbers, because like everybody knows the difference, right? Can someone, how many people can tell me why prices should be written in integers?
Because if you use floating, it's to some approximation of the value. When you add two numbers together, the approximations, you'll come up with a non-integral number if you're looking for.
How many people understood the explanation? Right, half, This is kind of complicated. If we said decimal number, maybe people would get it. But even this is sort of dicey. But yeah, you do need it for certain things. Recently, we started making Schema do a few more things. Action, because we all want action, right? What are actions? The web does things. You don't just look at pages about books. You don't just look at pages about movies. You watch the movie. You buy the book. You steal the video game. No, don't steal the video game. That's very naughty. I'm going to come back to video games in a minute. But for example, take a page like aeroflot.ru, as you might if your Russian's good. You can book a flight. You can reserve a seat. You can check in for your flight. You can find out where on earth they left your luggage after you've arrived. These are all things that the website does. And if you go into a modern browser, a modern search engine, email clients, Gmail, Yandex Mail, they start to show these things directly. Right? Your search engine result is no longer Aeroflot and the first line and a half of description about Aeroflot, or United Airlines, remember to fill in content here. It's actually got Iberia, reservar vuelo, book a flight, check in. Those links are in the result in the search engine page. Or you get an email with your flight ticket, and your email program actually has a button on it saying, this is a flight reservation, click here to check in. So you don't have to go hunting through and find the URL and do that stuff. If you mark up where the check-in thing is, then software, because it's clever, but not very, can actually find out and put that front and center in the user interface to make it faster for you to get where you're trying to go. So the idea of actions is to mark that stuff up. There are a few simple things. I have examples here which are kind of randomly selected. But basically, you have a potential action on a website somewhere. In this example, the type, I've used JSON-LD because I copied and pasted examples from the documentation. It's a search action. So you're searching for something, and the target, it's a pattern. It's example.com search equals something, and then we've got some parameters about it. So you have to have a name. The maximum length of the name is going to be 100. This tells you, when we put up the link in the email client or in the search engine results, we know what the parameters have to be. So we can put the right size text box, or we can tell you which fields are required before we bother sending you to the web page and finding out that, no, you've got to go back and fill half of it in again. And another example, a little bit more complication. It's like a 2-page example because it's really complex. That makes it 10 lines, 12 lines. Potential action, which is a buy action. Go on, spend money, do stuff. You have an entry point into the process. You can go buy something. And we know things like how the data should be encoded to send it there, what type of data you're going to get. These are just simple things that if you have your website and you want people to be able to get directly in it, you have to explain what you're asking for, right? Because what happens is that people don't necessarily start at your website. They're linking straight in from, as I said, their email client. In the Yandex browser, if I go to Aeroflot, in the address bar, I actually get a button right up in the address bar, the URL bar at the top. I get the book, flight, check in. I think there's one other one that we put there. So people go straight in. They never even see the search page.
Those are shown by the browser?
That's done by the browser, pulling the data out of the page. Or in our case, because our browser is linked to our search engine, when you get suggestions, some of those are your history, some of those are your search history, if you have a search history on Yandex. So the browser is doing processing. It might be going backwards and forwards to the server. It might not. You might say, no, don't do that, and it only does stuff in your history. But it can analyze the stuff and do it on the fly. And you'll get back a result, which is, we've completed the action, you've made the order, you've got an order number, you've got a confirmation number, and we're processing it. Get back to us, eventually, if you're lucky. No, it doesn't work like that. Every e-commerce system is perfect. All products are delivered on time, in good condition, if not earlier. Shh, don't tell her. As I said, the goal is keep it as simple as possible, always, right? So simple that it's hard for people to get it wrong if they think a bit, if they read the documentation. But as simple as possible is part of the how you should do things, but no simpler. Right? Don't make things too simple. So we've recently been working on putting in stuff about sports, sporting events, sporting teams, rock bands, TV series, and they turn out to be quite complicated collections of information. How many people here go to IMDb? Right, so I'm just about unique. I think I've been there twice. I don't go to the movies either. And how many people watch some TV series legitimately? Good job. So the example I picked here is San Francisco 49ers have a quarterback who's Joe Montana, right? If you're old enough. Sometimes. It turns out sometimes they have a quarterback who's not Joe Montana, actually for most of their history. And so you can say the 49ers have an athlete who's Joe Montana. And it's like, well, actually, they don't even have an athlete who's Joe Montana anymore. He's not part of the team. So how do we deal with that? And we came up with a beautifully complicated structure. Roles, which are work in progress still, add a layer of indirection, because every problem can be solved by a layer of indirection. So instead of saying the 49ers have an athlete who's Joe Montana, we We say the 49ers have an athlete, and there's this role. We have a few roles like performance roles, so actors. And the role is an abstract concept, right? Actually, whatever this role is, there's an athlete who does it, who's called Joe Montana, and there's a start date, which is 1979, and there's an end date, which is 1992, but I haven't put it in the example, and so on.
So is that athlete the same as that athlete?
This athlete is actually the same as this athlete. That's kind of dodgy, right? But it works.
So that has to be the same.
It doesn't have to be the same. It just turns out that we've only got one athlete property. So
Role is a subset of athlete, and the second statement, athlete is maybe a subset of role.
so we may have chosen the names badly. We probably have. But the basic idea is role is this just sort of abstract concept. I stole a picture from the internet that explains the idea, and it's slightly different. This example is Ghostbusters. Ghostbusters has an actor. Right? You could just say Ghostbusters has the actor Bill Murray. Done. And then you could say Bill Murray's character name is Dr. Peter Venkman. That's great, except that Bill Murray actually has a lot of character names in a lot of different places. And if you just say Bill Murray's character name is Dr. Peter Venkman, and Ghostbusters has Bill Murray, it's like, great, those are two statements, but they're separate. And you say Bill Murray's character name is also Joe Bloggs, you've got three statements, and you've got no way of figuring out how to separate them out. And that's why we put this performance role in the middle. So for Ghostbusters, there's an actor which has these various properties. And for some other movie, not being a movie buff, I can't really tell you anything else Bill Murray's ever been in, which is probably almost unique in this room. Yeah. So anyway, in these other movies, you have an actor who happens to be the same Bill Murray, but he has different attributes within the context of that role. So that sort of takes a tiny bit of thinking. This is really an abstract concept, right? Everything else so far in Schema has been pretty concrete.
Taking that one step property.
No, he must become a primary on his page, right? This page is Bill Murray. Yeah. No, it's a very good point, and you're right. On Bill Murray's page, this page is about Bill Murray, and Bill Murray has a performance role of actor in Ghostbusters. Which actually has a role where the movie is Ghostbusters and the character name is Peter Venkman, and he has another role where the movie is Caddyshack, and presumably he has a character name that all of you know, because you're all cleverer than me apparently. So we can describe almost everything. I'm going to come back to Bill Murray, but I'm going to talk a little bit about what we're doing now. It seems if you look at the vocabulary we have, we don't love hockey stadiums. We don't have a term for hockey stadium. It's like, this does not go down well in Russia. In Russia, hockey plays you. We don't have anything for game. Not that there are many games on the web, but apparently there's still a few people who like to play them. We don't have anything for translation. It's like you can mark up your book, but you can't say that it's a translation of another book. We have men's clothing store, and we have clothing store. There's nothing for children's clothing, or for lingerie, or for milliners, or for various other kinds of shops. Yet. Right? The basic point is, because this stuff is pragmatic and done on an as-needs basis, it's also kind of scrappy. So I'm going to talk a little bit about how the whole thing happens. It started out because R.V. Guha, a guy who, among other things, made the What's Related button in Netscape. Anyone remember Netscape? It had this button, What's Related. You can go and find things that were similar. Right? So really, this is partying like it's 1999. This is not new ideas. This is stuff that people have implemented, shipped, re-implemented, reimagined, and reshipped. We sort of opened it up. So right now, there's a public discussion forum, which is discussing vocabularies. What kind of things do we need? We need video games. We need hockey stadiums. You can describe a lake or a sea or a river, but you can't describe an island. So there's random gaps. We put, people write up their proposals and put them on the web somewhere, write to the list and say, look, here's my proposal, and the search engines decide. Right? The 4 search engines actually look at it and say, well, yeah, we'll do this. No, we don't think this is ready. Translation should be coming soon, but it was part of a giant proposal from a bunch of professional librarians. And we looked at their giant proposal and we said, yeah, that's really good. It's based on Ferber. Anyone know what Ferber is? Ferber is a standard for describing the relationship between various instances of a work and the work itself. So you have Romeo and Juliet, right? Everyone knows what Romeo and Juliet is. And then you have performances of Romeo and Juliet, and you have scripts of Romeo and Juliet, and you have performances based on particular scripts. And you have Baz Luhrmann's film of Romeo and Juliet, which is different from Roman Polanski's Romeo and Juliet, and describing how all of these things are related to each other. Hardcore librarians have really detailed ways of managing all of the relationships and being able to figure out what was descended from what. West Side Story is based on Romeo and Juliet, but it's not quite Romeo and Juliet, right? It's just the same story. So they had this huge thing. I said, yeah, Schema.org needs that, so you can describe the relationship between all of these creative works on the web. And we're like, yeah, professional librarians get that right sort of 80% of the time. We reckon webmasters will be lucky to get that right 8% of the time. So we're going to take some things out, like 99% of it. And we've got down to a few relationships that are really key and we think are clear enough and easily enough distinguished that they will go in. But they're not there yet. There's another part of the evolution, how it happens. We started out microdata. If you look at Schema.org today and you look at the FAQ, it says, why do you use microdata? And in the FAQ it says, well, microdata is a very pragmatic choice. It's very easy for webmasters to use. It's part of the HTML5 standard and lots of web developers know it. If you look at the GitHub page for Schema.org, there's a pull request saying, yeah, but we don't say that anymore because we no longer believe it. We discovered, for example, in microdata, it's very hard to change the order of the relationship, right? So doing that thing about Bill Murray is an actor in a movie, and a movie has actor Bill Murray, you need one property to point each way. That means you've got to have twice as many property names. That means the whole thing gets bloated and it's hard to process. RDFA and JSON-LD both just allow you to invert the direction of the relationship. So it's quite easy. You can do it with microdata, but it does your head in. You can't mix vocabularies in microdata. You say schema.org, everything's got to be schema.org terms. You can't use a Wikipedia term or some formal vocabulary term for medical conditions on top of that. There's no way of actually marking that correctly in microdata. people have JSON-LD and RDFA toolchains, because you can do that using JSON-LD and RDFA. Because what it doesn't say here is, don't say the formal data model of schema.org, the actual way we think about it underneath is RDF. So if you know RDF, it's like, we're really, really doing RDF. It's what we're really, really putting on 10% of the web. Right? All this famous semantic web link data, astronautic stuff that will never work, turns out to work really well if you do the simple things. But it makes the complex things possible, which is what we need, and what microdata is very bad for. As I said, we started at Google. We're kind of opening up, right? Over the last 2 or 3 years, the thing has become much more public, much more publicly driven. They added, Yahoo was sort of a launch partner, and then Microsoft got on board, and then Yandex got on board within a couple of months. We've recently shifted the actual content of the website from internal Google stuff that was horrible to try and deal with. We had to beg someone at Google to change things, to GitHub, so that people like me can just go and make a pull request and change the documentation. We're trying to put out more information about what we do. We're trying to put up more examples. We would like to do translations. We, Yandex, would particularly like to translate the stuff into Russian, because most of our target market speaks Russian. So what else is coming? We need to clean up the vocabulary. You should be able to, if you can describe a river as different from a sea or a canal, you should be able to describe an island as being an island, right? Because there are a few around the world. You go on holidays to them. That's what they're for. Australia, yeah. We need to do more work on roles and actions. Neither of them are really finished yet. They're quite complicated. We've spent a long time getting them to a point where we think they're workable. And we've only just started putting roles into the vocabulary. But for stuff like TV series, we're going to need a lot more than what we've got already. Or for sporting statistics, the history of cricket matches, other important things. And relating to other vocabularies. So do people know Facebook's Open Graph? It's similar, right? It's metadata you put in your pages, and it basically provides the kind of information that Facebook systems are interested in. This is about a person, and I have a cat, and here's a picture of me and my cat, who is my friend. So I had to get my cat a Facebook account so I could have a friend. Open Graph is very, very simple. There are more pages using Open Graph than using schema.org. There's a lot of Open Graph, but it's also very, very shallow. So you might have a few statements in Open Graph where you'll find pages right now shipping big blocks of schema.org data. So overall, we find more data recorded using schema.org, but both of these things they're really big, right? And they're really big because search engines use them. And we use Open Graph stuff as well, obviously, because we can process it automatically. One of the little lessons here is if you're not looking at this stuff and the other people are, they're ahead of you. So remember that. And we don't want to put everything into schema.org, partly because if you look at the vocabulary, it's pretty clear that we're not very good at figuring out everything you need. Partly because in lots of specialized fields, people have already done, 25, 30 years, 4 centuries of work on classifying things, and they actually have all of the stuff that you need available on the web already. We don't need to put all of the Linnaean classifications of biological names into schema.org. You could just use that from some other vocabulary if we make it clear how you do that. Fine print is, trademarks belong to their owners. None of this stuff is guaranteed. We move fast and break stuff. That's probably a good thing. A lot of the things we do first off are not very good. So we have changed terms, we deprecate terms. If you look in the vocabulary, you'll find a bunch of things where it says, the term that you see, if you look at the detail page of that, it will actually say, yeah, this has been deprecated, or this term deprecates some old term. We just publish the current version. The search engines individually have the information about the old deprecated term. We individually decide whether we're going to keep on supporting it or not, and that really depends on individually whether we find it in our index. Different search engines have different footprints over the web, as it were, and so they actually see different stuff. The statistics are quite different if you look at what Google indexes and what Yandex indexes. There's a whole lot in common, but the whole long tail stuff, those indexes actually look quite different. They're different shapes and different content. And that's what I wanted to tell you about schema.org. It is now your chance, if you'd like to ask questions, which I may or may not be able to answer. Thank you. I'll start from the front.
I just looked on my...
39 and a half. That's not as good as it was, but yeah, it's a big company. Yeah, it's got 8,000 employees or something.
We hear so much about China, we don't
Right. The question here first.
So is the microdata pretty much being abandoned? Is that?
No. Sadly, once you go out promising to the web that if they put microdata there and you get a lot of microdata and a lot of that stuff never changes, we can't sort of just abandon it. But if you start new today, I would definitely encourage you not to use microdata. You'll find other people who say, yeah, it's not that bad. You find people have their tools set up to do it. Part of the microdata thing is our fault. When the Yandex engineers were first looking at schema.org, they're like, yeah, microdata, that's a great thing. That looks really simple. The spec is fairly well written. It's easy to implement. The RDFA spec at the time wasn't as good. They went out preaching microdata, to Russia. So in our indexes, microdata is much higher proportion than in any other search engine's index. Yeah, so a year ago, pretty much all the documentation said microdata. And as I say, our FAQ still says, why do you only use microdata? And there's an answer about how microdata is so good. And hopefully my pull request will be accepted today or tomorrow, and the FAQ will be changed to say, actually, it seemed like a pragmatic decision at the time, turned out not to be so good. All the search engines now index other formats as well. And we'll sort of look and see. The benefit of RDFA is that it's marked up page content, right? It's stuff in the page. So you look at your page, you change your page, and you see what you're changing. It doesn't get forgotten and lost in a corner. The benefit of JSON LD is that it's JSON. It's really easy for people who are writing tools to process it and change it and manipulate it and check that it's up to date. We validate that's the webmaster Yandex.com is a bunch of tools for webmaster, and microtest.xml is a validator for microdata and RDFA and JSON. You can check what data comes out of the thing. So I suspect we will continue de-emphasizing microdata until we stop saying it at all. There is also politics involved. Microdata came out of Google and it was put into HTML5, as far as I can tell, specifically because Hixie hates RDF. Microdata is the only format we use which is not one-to-one mappable with RDF. It's kind of, you can do it, but it's painful. And that turns out to mean interesting things that you can do with RDF data are much harder to do with microdata. So yeah.
Is this the Yandex browser?
This is the Yandex browser that I'm using, yeah.
Where are the slides? Are they the slide that you showed?
The slides are sitting here at the moment. I will give them to John and Thomas. If anyone wants to give me a USB key, I'll give you a copy. It's no big deal. Yeah, so search engines are sort of the obvious consumers, but in fact, the data is there. Anything, and this is a bit terminology question, right? Things that go looking at content on the web, they are generally some kind of search engine, but not always. I use the example of the browser, like directly reading into pages. And with the Actions stuff, Gmail, Yandex Mail actively use that right now in the email client. So you get an email, it's got the Actions schema.org data encoded somewhere in the email, and they use that to put right up the top of the email action buttons. All kinds of applications that can use data can be built on this. So part of the question is, what are they going to do? Because it's the search engine guys who make the decisions about what goes in, it's likely that it will be kind of search engine-y focused for a fair while. But you could imagine like microblogging platform stuff, Twitter and Weibo and those guys taking data and being able to connect things up. LinkedIn might take data and actually use data about people to make new connections. The open graph stuff that Facebook does, it's blindingly obvious to all of us, including Facebook, that if we figure out how to combine these things, then we can make more interesting. We can learn more about the web, we can learn more about the information there, and we can make interesting applications that are not so much search engine-y. You can build games on it. So people have things like geocaching games, and so stuff that actually applies to the real world. There's a lot of things you can do with information that are not just searching it, that are actually acting on it and building something on top. Yeah, it's probably not the only thing they're using. I mean, Google. I don't know the internals of all the stuff they're doing, but yeah, it's where we're going. We also use heuristics, right? We do text analysis of airplane pages to find out where their booking thing is, and we can sort of do that. And we're less likely to do it for bus companies because there's more of them, and it's less reliable. Because we get more and more complicated heuristics. If we can get clean data, then that's what we want to encourage. So yes, we use it, and yes, it's helpful for us to do so. Yeah, that's actually the normal case. The question is, can you use schema.org data without the browser going to schema.org and looking? And it's like, yeah, browsers typically won't go to schema.org and look stuff up. Search engines will. The browsers hard code a few bits of schema that are interesting to them and that they have some useful way of processing, and they've got that built in the browser. It's not like they're going to schema and looking up thousands of properties and figuring out the sort of data manipulations. If you had a real graph crawling visualizer, then it might do that kind of thing, but that's a fairly specialized application. Most of the time, the browser's not going to go and check out schema.org and download it to see what's happening.
Just so you know, I believe that the subset that's in schema.org is the right subset, but it's
so I don't, and I'm one of the guys that chooses it.
Can you explain the question?
Okay, so the question is, for example, in BibX, but in lots of things, we take a very restricted subset of a large, carefully thought out vocabulary. And people who worked on that vocabulary or who used it say, and the example is the library cataloging stuff. They say, but this stuff is carefully thought out and covers all the information that people will want, and you've only got like 3 properties that do a really half-baked job of enabling that data to be recorded. And the answer is, yeah, that's exactly right. And the reason is the half-baked job we do, we're aiming at Joe web developer. And she's quite bright, brilliant CSS designer, super JavaScript chops, never really spent 5 years studying library science, and is just not going to read the Ferber spec and get it all there. Joe librarian doesn't know squat about CSS or JavaScript, can't even get HTML right, but actually understands how to classify all of this data perfectly accurately. So if you're a library, and the people like the BNF, the National Library of France, and national libraries are using this stuff, if you're a library, you need to have proper library quality information. And you get that by having proper librarian quality librarians put in the right kind of information in your system. And you can put a subset of that as schema.org data. Right? The reason for using RDFA is, and not microdata, is so you can mix Ferber, for example, and schema.org in the same page. It's trivial to do, right? You just tag, a couple of things might have 2 tags, because the schema.org name is something and the Ferber name is something else. But basically you have the same information. And the BNF does it because 80% of the document records, like the final records that get found in their search system, don't come from their own search interface. So people go into a search engine, look up some item in the library, and go from the search engine directly to the actual book record that says the ISBN and where on the shelf it is and how long it's been overdue, rather than going through the system. So yeah, those high quality information systems, they are the high quality information. What's on schema.org is a rough subset that's good enough for the web and that's simple enough not to get broken. Right? If we asked all web developers to use Ferber, what we would do is generate so much garbage Ferber on top that you would lose the quality information because people would stop processing it. So you have different levels of quality for different jobs. So McDonald's is not, I hate to say it, McDonald's is not the one true restaurant. Right? But El Bulli is closed. So, you have them both. They serve different needs, and it turns out that individual people can eat in different places, can do different things according to the context of what they're doing today. And please, please, please do not go and tell your librarians that they should only use the schema.org data set. That would be like burning down 2/3 of the library. Don't knock card catalogs. They're very cool. It's like, because it's really hard in most library systems now to scribble a note on the side saying, by the way, this book is really tiny. It's next to the one called something, which you can actually find on the shelf. The true information systems are the ones that you need to have for professionals. But for the web, for ordinary people finding ordinary stuff, this is a good enough, fast enough, and won't break solution. Yeah, so the average Joe developer occasionally does this, and pretty much, have a look at what's on the web. Try and find out whether there's 40 proposals already, and you're just making a 41st, because that will just mean we've got to read this one as well before we figure out which one we're going to do. This public vocabs at w3.org, that's a mailing list that anyone in the universe can subscribe to. It's for discussion. It's not just for schema.org. It's actually for discussion of vocabularies that are meant to be used by the general web. So FOF, for a friend of a friend. Shock, which is a social interaction vocabulary. A few other things can be discussed there as well. But that's where Joe Developer goes to say, we should have this, and because all the schema.org people read that, and they say, oh, yeah, we should. And we do get a bunch of useful contributions already.
So is the wiki for schema.org still on w3.org?
Yeah, there's a wiki on w3.org. There are individual groups set up their own wikis. So it's not like there's one monolithic proposal wiki. There are wikis on W3C that you can use, but you don't have to. I'm actually going to have to stop because we're going to get kicked out of the building. So thank you very much for your questions. If you have more questions, Schema.org is the documentation which is permanently almost up to date with a few errors. There's a GitHub where that site is actually stored, the webmaster thing, and anyone can send an email to Charles at this address. I promise you'll get a reply. Thank you.